This is sunlight dying behind the moon. For nearly an hour, the Artemis 2 crew watched the solar corona stream around the enormous lunar limb. During their lunar flyby in April 2026, these 4 brave astronauts documented our closest neighbor using high-resolution sensors, capturing unique perspectives that provide vital new data for lunar scientists back on Earth. These images show the moon as a brutal, 3-dimensional world, where deep shadows and sharp ridges replace the flat, glowing disks seen from Earth. From the approaching Orion spacecraft, the densely cratered left limb is shown in high contrast, shaped by billions of years of impacts. The visual difference between this rugged edge and the smoother center reveals the moon's age. The bright regions are the oldest lunar highlands. There is no atmosphere here to scatter light. The transition from the lunar surface to the vacuum of space is an absolute black line with no horizon glow. Without an atmosphere, there is no weather to erode these features. Ridges and crater rims remain exactly as they were millions of years ago, preserving a physical, pristine record that is 4.5 billion years old. Earth's tectonic plates and climate have recycled our own planetary crust many times over. The moon's surface holds the physical evidence of early solar system history that has been completely erased from our own world. During the crew's observation period, the spacecraft skimmed just above the surface to capture fine-grained geological detail. This is the Oriental Basin. It was formed when a massive asteroid impact cracked the lunar crust, allowing liquid lava to well up from deep underground and freeze into this dark, circular basin. The impact was so powerful it excavated billions of tons of rock, ejecting debris hundreds of miles in every direction. This diagram shows how that debris traveled. Huge fragments of rock landed in sequence, carving straight lines of secondary craters known as crater chains. Fresh rock exposed by a new impact, like the rays at Glushko crater, appears bright and reflective. Over billions of years, solar radiation and micrometeorites slowly darken the surface. On Earth, mountains erode and crust is subducted back into the mantle, but the moon provides a stable, physical map of the violent collisions that shaped the early solar system. Moving toward the lunar limb, it crosses the terminator, the line where day meets night. Low-angle sunlight reveals the true topography. Sharp rims indicate recent impacts, while softened edges show where ancient craters were ground down by billions of years of strikes. Tilting the camera reveals the lunar horizon, an expanse of dust and rock meeting the black vacuum of space. The next crew of Artemis astronauts will stand on this horizon, walking across the surface we are now seeing in such high resolution. When the spacecraft passes behind the moon, it enters the shadow and radio silence of the far side. The terrain here is lit only by a thin sliver of sunlight catching the highest peaks of the ancient topography. There is no radio contact with Earth and zero Earth shine to light the ground. The crew is surrounded by deep space. Then, ascending above the dark lunar limb, the crew captured this image. From this vantage point, Earth is a thin sliver of blue. It holds every person and every city in human history within a single small crescent. The flyby brought 4 humans to this closest point, where they spent an hour watching the solar corona bloom around the edge of the moon. Artemis is about establishing a permanent presence on the lunar surface, finally allowing us to study the physical evidence of a history that dates back 4.5 billion years.